Welcome to this explainer. Let's just dive right in. If you've ever banged your head against the keyboard trying to use standard AI web interfaces for complex design tasks, like trying to convert a flat image into an editable Photoshop file, you already know it usually ends in massive frustration. Well, today, we are looking at a real game changer. The bggg-skills repository by the developer Bing and Gandija. It's a collection of open-source Codex skills that completely rethinks this entire process by giving AI the ability to actually self-correct. Here is our roadmap for today. We'll start with the AI workflow problem. Look at the Codex reasoning loop. Dive into 3 core Codex skills, peek under the hood at the architecture, and wrap up with current limitations and what the future holds. All right, part 1, the AI workflow problem. And specifically, we need to talk about the limits of one-shot generation. So, the fundamental flaw with traditional AI web interfaces is that they essentially operate like a broken vending machine. You put your request in, ask ChatGPT for a complex image-to-PSD conversion, and it just runs once. It spits out a single, flawed file. The text is baked right into the background, there are visible visual artifacts all over the place, and there's absolutely zero quality control. But the Codex framework, it is an entirely different beast. It runs arbitrary code in a sandboxed environment with a built-in reasoning loop. This means it actively checks its own intermediate results. If the quality falls short, it doesn't just give up. It self-corrects and tries again. It becomes an active participant in your workflow, not just a one-and-done guesser. Moving right along to part 2, the Codex reasoning loop. Let's see this self-correcting code in action, because this is where it translates into a massive advantage for automation engineers. To really grasp why that self-correction matters, let's look at a test run on a complex conference poster. When that poster was pushed through a standard single-pass web interface, the AI totally gave up after separating just 7 layers. And to make matters worse, those 7 layers were completely unusable. They were plagued with artifacts, the text was merged. It was a completely dead-end file for any designer trying to actually edit that poster. But flip the script. You process that exact same poster through the Codex reasoning loop, and boom, you get 12 perfectly separated, clean layers. How is that even possible? Well, mid-run, Codex actually noticed its own mistakes. It detected its own messy layer edges, automatically adjusted its Python parameters on the fly, and reran the script until it got it right. A single-pass tool simply cannot do that. Which brings us perfectly to part 3, the 3 core Codex skills that currently make up the bggg-skills toolkit. So the repository currently packages all of this self-correcting logic into 3 distinct installable directories. The first one is called Image-to-PSD. This uses that reasoning loop we just talked about to meticulously reconstruct editable Photoshop files from 1 or more flat images. It uses Codex and image generation to assist in layer splitting, it handles color-based separation, and it can even convert white backgrounds to transparent automatically. But honestly, what's truly wild here is the pure Python PSD writing. It does all of this natively in Python. That means you don't even need expensive Adobe software installed on your machine to generate these files. The second skill in the toolkit, Image-to-PPT, tackles another notoriously painful task, iterative component detection. If you've ever tried to turn a flat design mockup, an HTML file, an SVG, or even just a quick screenshot into a native editable PowerPoint presentation, you know a single pass almost never works out. This skill uses the Codex loop to actually recover text boxes and meticulously rebuild native shapes. It parses everything directly into a fully editable PPTX file. It's incredibly handy. Now, seeing those 2 capabilities, you are probably asking yourself right now, okay, these are cool, but they're ultimately just deterministic Python scripts orchestrated by Codex. How on earth do these skills improve over time without a human constantly going in and rewriting the code? Well, meet Taoti. Named after a mythological creature from Chinese folklore that's famous for devouring everything in its path, this is a literal meta-skill. Taoti analyzes other skills, figures out what their strengths are, and incrementally upgrades a target skill by basically eating those advantages. Just think about that for a second. An open-source tool that actively absorbs other code to improve itself. It's just a completely brilliant concept. Let's crack this open a bit more. Part 4, Under the Hood. Let's look at the actual architecture and how you install these skills locally. The creator set this up with a highly standardized architecture. The absolute brains of the operation is the skl.md file. That is what Codex reads to understand the trigger conditions and the execution logic. You've also got your standard README files for us humans, a scripts folder for the actual Python code, and vitally, a local projects folder. And this is key because only a placeholder is committed to GitHub for that runtime output directory. All of your generated files and proprietary designs stay securely on your local machine. They are kept completely off the public internet. Because of this clean, standardized structure, deployment is an absolute breeze. These act as simple drop-in directories. You just clone the GitHub repo, copy or symlink the specific skill folder you want directly into your local Codex skills directory, and run a quick pip install for the Python dependencies. And that's literally it. It is modular, it's clean, and it's highly effective for local deployment. And finally, part 5, limitations and the future. Let's ground ourselves in reality here and look at current constraints. So before we wrap up, it is absolutely crucial to note the current documented limitations of this open source project. It's not all sunshine and rainbows just yet. While the Image-to-PSD tool is incredibly powerful, there are caveats. For instance, text layers are currently exported as rasterized images. Yes, you can move them around in Photoshop, but you can't just double-click and edit the vector text live right now. Also, all of that self-correction magic fundamentally relies on having that codex dependency. If you just run the Python scripts directly on their own, you skip the quality checks entirely. Furthermore, output file management is completely manual on your local machine. And right now, the primary documentation is in Chinese, with the English translation files sometimes lagging a bit behind. But here is the real kicker. This is an MIT-licensed, completely open-source repository. The creator is actively encouraging developers to build and contribute brand new skills. As long as you follow the standardized folder layout we just reviewed, making sure you have that skill.md file to instruct codex, your Python scripts, and your local project folders, literally anyone can expand this toolkit. So I will leave you with this final, somewhat mind-bending thought. If an early-stage open-source repository already features a meta-skill like Tau-T that can analyze and absorb the strengths of other code to self-improve, what will a self-evolving AI design toolkit be capable of achieving a year from now? The gap between a machine just taking a one-shot guess and a machine utilizing true automated reasoning is closing faster than ever. Thanks for joining me on this explainer, and keep exploring.